Good morning, students. Today we learn about relative motion. What is relative motion? When we talk about relative motion, what is relative term? What is relative motion? We discuss it step by step. Firstly, we think about that what is velocity? When we talk about any velocity, any distance, any displacement, then we think that the velocity of an object with respect to which point means we think about velocity by using reference point, by using a reference like that. This is a ground. A object is moving with 5 meter per second with respect to ground. We are talking that the object is moving with respect to ground. This is moving with respect to ground. Okay. Now we talk about when an object is moving in car. What I am saying? An object is moving in car means this is a car and moving on road with 5 meter per second, and on same road adjacent to this is a road adjacent to car another vehicle is coming with 6 meter per second. Okay, when both the car at same place, let's see a point A, this is a car and this is a car, then we think that first car, second car. Then we see that the car 1 is moving backward to 1 meter per second speed. Why? Actually, the speed of car 2 is 6 meter per second and 1 is 5 meter per second. When both are adjacent, then this is thinking that the observer in car 1 see that car 2 is moving forward with 1 meter per second speed and this is moving backward to 1 meter per second. Okay, the term relative is coming from there. This is relative term. We are thinking, we are seeing relatively to car. We are saying that the car 1 is moving backward to with speed 1 meter per second with respect to car 2. The relative term comes from here. This is relative velocity. Similarly, relative acceleration, relative displacement, and so on. The relative term comes from here. The relative motion is talking about motion. The relative term in motion is known as relative motion. Okay. Then now we take an example of relative motion. What is relative motion? ये तो हम जान चुके हैं. And now the example of relative motion. This is a ground and a car 1 is moving with 2 meter per second speed, velocity, okay, in this direction, and acceleration is 3 meter per second square, and car 2, this is car 2, moving opposite to car 1 with speed 3 meter per second and acceleration is 4 meter per 2 ले लेते हैं 2 meter per second square. Okay. Now this problem can be solved by both the general method and by relative method. we have to find time at which both cars meet. Okay, both cars will meet, and the separation between both cars is 100 meter. Okay, uh, we can solve by general method and relative motion. Firstly, we have to solve it by relative motion. Okay, by relatively, how can we solve it? Let's see. This is car 1. I am seeing the car 2 relatively to car 1. I am the observer and I am in car 1. This is observer, I am observer and I am in car 1. I am saying that I am at rest with respect to car 1 because I am car 1, and I am saying that I am at rest not with respect to ground, with respect to car 1 because I am in car 1. Okay, and this is car 2 which is moving with 3 meter per second in this direction and 2 meter per second square acceleration with acceleration in this direction. Okay, but we can't neglect the speed and acceleration of car 1. We will see these velocities and acceleration in car 2 relatively because we are seeing relatively. Then the relative velocity are seen in car 2 and relative acceleration will see in car 2. Okay, so relative velocity of car 2 with respect to car 1, we have to find it firstly, and relative acceleration of car 2 with respect to car 1, we have to find that. Okay, firstly we have to find that. Okay, so relative velocity of car 2 with respect to car 1 is velocity of car 2 minus velocity of car 1. We have to see that this is coming from where. Okay, firstly we see that this is object 1 and this is object 2. This is separated by 50 meter. We can say that object 2 is 50 meter more than, further 50 meter further than object 1. So we have to say that object 2 is relatively with object 1 is 50 meter further. This is relative term. So we can say that displacement, distance, relative displacement, relative distance of object 2 with respect to object 1 is distance. This is reference point. We have to take it reference point. Okay, distance or displacement of object 2 from reference point minus distance or displacement of object 1 with respect to the reference point. Okay, this is 50 meter minus 0 is 50. So this is relative term, relative displacement or distance. Similarly, relative velocity of object 1 with respect to object 2 is velocity of object 1 minus velocity of object 2. Okay. Now we are going again to this problem. Now we can understand easily how this formula is coming. Okay, this formula is coming from relative term. Okay, velocity of car 2 with respect to car 1 is velocity of car 2 minus velocity of car 1 is what? This one 3 and car 1 का velocity 2 but minus of 2. Why? car 2 की the speed of car 2 is 3 meter per second in this direction and car 1 is 2 meter per second in this direction. So direction is changed in relative velocity क्योंकि relative velocity is because relative velocity is a vector quantity so we have to take direction. Okay, 3 minus minus 2 is 5. Similarly, relative acceleration of car 2 with respect to car 1 is what? 2 minus minus 3. Direction will clear. So 5 meter per second. This is meter per second. The relative velocity of car 2 is with respect to car 1 is 5 meter per second and relative acceleration of car 2 with respect to car 1 is 5 meter per second square. Okay, so we can replace it with relative velocity of car 2 with respect to car 1 is 5 meter per second and relative acceleration of car 2 with respect to car 1 is 5 meter per second square और उसका meter per second. Okay, ये लास्ट में. Okay, separation between both cars is 100 meter. Now I am saying that I am at rest because I am in car 1 and relative velocity we can see easily in car 2 this and this, and I am saying that I am at rest, I am not moving. Car 2 will move to me and and come to me by traveling 100 meter distance. Okay, then we can solve it easily. S is equal to ut plus half at square. This is the equation of motion we can use here, and S is what? 100 and u is what? This one 5t plus half. A is what? 5 and t square. Okay, first equation we can solve easily. Time from here. Okay, now we have to recheck it. This formula is correct or not. Okay, so we have to solve it by general formula. This is solved by relative method and by general. We have to solve it by general method. General method is what? This is car 1 and this is car 2 and separation between both car is 100 meter, and we can say easily that some distance have to travel car 2, car 1 and some distance have to travel car 2 within time t and come close. Both car will travel 100 meters distance in time t. It will meet after time t. Okay, then we can see here car 1 speed is what? 2 meter per second and well acceleration is 3 meter per second square, and car 2 has 3 meter per second and 2 meter per second square. Okay, so first equation for car 1 is what? T. Let's see. We can say that x distance it traveled by car 1 in time t, and remaining distance 100 minus x is traveled by car 1. Okay, this is entered. So we can easily use here s is equal to ut plus half at square. For car 1, for car 1 is what? S is equal to ut plus half at square. U is what? 2 t plus half is what? 3 t square. And for car 1, car 2 is what? This one is s. 100 minus x is equal to u. U is what? 3 meter per second. 3t plus half at square is what? 2t square. Okay. Equation 1, equation 2. We have to add it. We can add it easily. Both equations. If we add it, this is what? 100 is equal to 5t plus half 5t square. Okay. This is equation 3rd by general method. यहाँ से हम we can easily solve t. If we are right, then time solved by here and time solved by here will be same. Okay, and see that this equation and this equation is same. By this, from this we can easily say that relative motion and general method, by relative motion, by relative method and by general method, we can easily solve this problem by both methods, and both methods are correct. We can say that by relative motion, if I am solving, this method is also correct. By general, this method is also correct. But in some cases, the problem are so confusing, so calculative, then we have to use relative method to solve easily, to reduce our effort. We can see here we have to use 2 equations and there only 1 equation. Therefore, we can easily say that relative method reduces our effort, our time. In our competitive exams, we can use it easily. Thank you very much. If you like it, then share it.